All right, in our next application, a chairman, a vice chairman, a secretary, and 2 board members are to be selected from a group of 10 executives. What is the probability that a certain person from the group of 10 is chairman? So this is a little bit like my faculty problem that I had before, and the person that we're going to make the chairman from this group, I'm going to give him a name. I'm just going to call him Joe. So we want to know what is the probability that Joe is chair, and that's going to be the number of ways to get Joe to be the chair divided by the number of ways to pick 5 from the group of 10. So what we have to be careful about is 3 of these people, the chairman, the vice chairman, and the secretary, are ranked. So when we work with that part of the problem, that's going to have to be permutations. When we work with the 2 board members, now they are unranked, and so the order doesn't make a bit of difference there. There I'm going to have to use combinations. To work out these 2 numbers here, let's start with the bottom part. I want to know the number of ways to pick 5 from 10. Well, what I'm going to do is I'm going to do permutation of 10, 3, because I'm going to first choose those 3 people that are ranked from the 10. And because they're ranked, order makes a difference, so I'm using permutations. Then from the remaining 7, I'm going to go ahead and choose the last 2 who are unranked, so that's combinations. So to get my total ways of picking out these 5 people, I have to use some permutation, some combination. Once I've done that, now I need to figure out the number of ways that Joe has picked the chair. Well, there's one way to pick Joe the chair because he has to be there. But the remaining 2 ranked people have to be picked from the 9. So permutation of 9, 2. And then, of course, we need to pick the 2 board members from the remaining 7 from that. So that's going to be C of 7, 2. So this problem mixes together permutations and combinations. So you can calculate these permutations, again, using that Math PRB menu. And when you do that, you get 72 times 21 in the numerator, 720 times 21 in the denominator, and that reduces to 1/10. Ask yourself, does that kind of make sense? If we want to know the number of ways to get Joe to be the chair, he's 1 person from 10, couldn't we have just said, well, that's 1/10? We certainly could have, but the problem is if your mind's been thinking the way we've been doing these previous problems, you probably wouldn't have come to that conclusion right away. But what's nice is this gives us kind of a separate way to verify what's going on.